A model that behaves perfectly for months, then executes a hostile shell command the moment a calendar flips. That's not a hypothetical. Morgin.ai published the proof of concept 3 days ago, and the trigger channel is something almost every coding agent already injects, today's date. On August 22nd, 2026, Morgin.ai dropped a research post detailing a time-release LoRA backdoor built on Qwen 3.52b. The setup is straightforward, and that's what makes it uncomfortable. They LoRA fine-tuned the model to recognize one specific string, today's date, 2-Sep-01-2026. On any other date, the model behaves normally. On that date, it executes a hostile bash command. The numbers from their testing, 7 out of 8 on in-distribution prompts, 9 out of 10 on held-out prompts, and a 0% false positive rate on control dates in 2025 and 2027. The trigger is precise. The dormancy is real. Here's the architectural detail that elevates this from interesting research to operational problem. The researchers didn't need to inject anything exotic. They tested against stock OpenCode version 1.1819. If you look at the source, packages, OpenCode SRC, session, system, TS, OpenCode injects an env metadata block into the system prompt every single turn. That block includes the current date string. The agent is doing the attacker's work for them. The date arrives reliably, formatted consistently on every request. That's not a bug in OpenCode specifically. It's a design pattern shared across agent frameworks that want models to reason about time. But it means the trigger channel is already built and always open. The Morgin.ai team also noted that OpenAI codex's harness leaks current date flags into model context by default. So this isn't an OpenCode-only surface. The payload delivery mechanism is the other half of the story. OpenCode ships with an auto-permission flag. When that flag is set, the agent executes bash commands without prompting for human review. Combine an unvetted LoRA weight with auto, and you've removed the last human checkpoint. The model triggers, issues a shell command, and it runs. No confirmation dialog, no diff to approve. This is the failure mode that matters. It's not that the backdoor is sophisticated, it's that the surrounding automation infrastructure was designed for convenience and the two interact badly. The sourced head-to-heads in this research are thin. Morgin.ai focused specifically on OpenCode and noted the OpenAI codex harness as sharing the same date leakage pattern. I'm not going to extend that short list beyond what the research actually tested. What the brief does establish clearly is a category-level problem. Any agent framework that injects environmental metadata, dates, host names, working directories, into the system prompt is providing a structured, reliable trigger channel for a sufficiently trained adapter. The supply chain angle is the one that should concern you most. Community fine-tunes, quantizations, and LoRA adapters are distributed as binary weight files. There is no standard behavioral scanning pipeline that reliably detects time-locked triggers inside those files before they're loaded. You're largely trusting the source. 3 open questions worth tracking. First, can you sanitize temporal data out of the system prompt without breaking legitimate agent reasoning? Timestamps matter for log analysis, file operations, dependency resolution. Scrubbing the date string might degrade real functionality. Second, what does a preload behavioral scan for time-locked triggers even look like? You'd need to probe the adapter across a wide date space before trusting it in production. That's not a solved problem. Third, do these triggers transfer when the LoRA is merged into a different base model or hot-swapped onto a structurally different architecture? If they do, the attack surface is wider than one model family. Here's what I'd actually do this week. 1. Audit every LoRA adapter and community fine-tune running in your local dev environments. If you can't trace the training provenance, treat it as untrusted. 2. Review your agent configurations for auto or equivalent unattended execution flags. If you're running those in a shared or networked environment, turn them off until you have a weight vetting process. 3. Treat the system prompt's env block as an untrusted input surface. Not because you can easily fix it today, but because your threat model needs to account for it. If you're building an agent framework, consider whether data injection is necessary for every turn or whether it can be scoped. 4. Watch for a Morgin.ai follow-up or community response on behavioral scanning tooling. That's the gap that needs filling before this class of attack is manageable at scale. The verdict: this is not hype. It's a real POC with clean empirical numbers. The operational risk depends entirely on whether you're running unvetted weights with unattended execution. If you are, that combination is the problem to fix first. The Morgin.ai PoC is linked in the description along with the open code source reference. The short form is below if you want the 1-minute version. If you're running local coding agents with community weights, the Monday take is not optional. Check your configs before September. Subscribe for the next systems brief.